Hello everybody. Today this is easy calculus number 4. We talk about infinity. The infinity is the number that some mathematician say it's invented by devil, or some mathematician even went suicide, and a lot of smart people are confused, argued, and depressed in the past. This is true, and I'm welcoming you to this. The word infinity, the infinity is used in calculus, so it's a fun part of learning calculus. What's infinity? Okay, so we learned about infinitesimal number, the number that close to 8. It's close forever. So delta goes to 0 and 8 plus delta. The question is this 8? No matter how close delta is 0, there are some quantities. So isn't it always like this? Which is correct? Okay, so one smart mathematician finally solved using epsilon delta logic. Okay, it's not completely solved, but it's accepted. Okay, by saying limit. And what this limit means, that limit makes this okay to say. Yeah, it's look like this is always larger than 8, but limit, when you say limit, means you go all the way to 0, then this become 8. Now, if you remember previous video, we talk about epsilon delta logic. Epsilon delta logic is like, okay, the kids compete with a large number. You give me any large number, my number is going to be larger. Okay, so kids quote large number. Another kid said, I have an infinity in my pocket, I can beat you. That whatever the number you quote plus 1 is my number, so he win, right? It's the same logic here. Tell me how much difference between them. Okay, so some number, its difference is smaller than epsilon. Okay, you tell me the difference. I move delta closer to 0, then this epsilon, I can make the number you quote epsilon even smaller, and I win. So I can say this is equivalent to 8. We can say definitely this is equivalent. Okay, but delta going to 0 is kind of weak. We have to say limit, and limit is like, say you have a volume slide, right? You move the slide, but volume slide doesn't have 0. Okay, this is 0.01. You slide to there, I can still hear the sound. Let's move all the way. I can still move the sound. Okay, limit means you move all the way infinitely. Okay, so it's kind of solved the problem, epsilon delta logic, but it's included the problem into this limit. And this limit, what the problem is, it's include infinity, the concept of infinity. And concept of infinity is very confusing, and people are annoyed so much. Okay, for example, say delta limit delta goes to 0 and no limit delta going to 0 delta square. So which is bigger? Well, obviously this guy is bigger, right? Is it? Not really. Not really. This is smaller, because if this is 0.1, this is 0.01. It's smaller. So this is smaller, right? So this guy is smaller than this, no matter how far the delta goes to 0, right? But if you take a ratio, what's happened? Delta over delta square is going to be delta go to 0. Delta go to 0. It's going to be huge number. The ratio is a huge number. Okay. So what you call this huge number? Infinity. Okay. So it's not infinity yet. You put the limit. Okay, you move delta to 0 forever, then become infinity. So this become infinity. Before you move, you don't move forever. Delta get close to 0. It's still somewhere before infinity. If you put the limit, it means you go all the way, move the slide all the way forever. Okay, then it's become infinity. Now what's infinity? Okay, delta over delta cube is also goes infinity, right? What's the difference between this infinity and this infinity? Okay, now before we get that, we talk about ratio of infinitesimal number. The ratio of infinitesimal number, so it can be 0 or some number which is derivative dy dx, or sometimes infinity. Okay, the ratio can be anything. It can go infinity, it can go 0, it can go some number we can handle. Okay, so ratio of infinitesimal number, delta x goes to 0, can produce derivative. Okay, here's a one thought. Okay, suppose you have triangle A, and this length is A, this length A and A. You take midpoint and fold it. So this gonna be A, right? Because this is same as this, and this gonna be A, the same as this. Okay, so you have a ants moving. You have a path 1 along x. That it takes A, right? But ants moving this triangle, path 2 is a 2A, right? Okay, you fold it again, fold it again, fold it again. You fold it infinitely. So this triangle path become eventually same as A. If you fold infinitely, this 2A become A. Is that possible? Okay, the path 1 length and the path to length was a over 2a before folding infinitely, and folding infinitely, okay, and what's happened, the ratio is the same no matter how many times you fold it. So ratio is always 1 over 2, right? Okay, so but wait a minute, this triangle path, each length become infinitely small, and you put a lot of small things here, isn't it eventually become same as a? Well, no, really. This very tiny one, you multiply infinite number, so it's like 0 plus times infinite is 2a forever. Okay, so what do you mean? This, the ratio is same, and ratio stays same no matter how many times you fold. So you created the example of almost 0 lengths. If you have many of them, infinite amount, then become 2a. So this one we use it for integral. Okay, so this concept, if you have infinite number of almost 0, it's going to be 0 when you keep folding. It may end up with, again, same, end up with 0, infinite, or some number, 2a. Okay, so infinite, some ratio, infinitesimal number can be 0, some number, normal number, infinite. For example, this delta over 1, delta square, this goes infinite, this goes infinite, infinite over infinite, can be anything. And 0 times infinite can be also 0 or normal number or infinite. Okay, okay, there are another case we're not sure about. Let's talk about infinite minus infinite. What happened? Say it give you challenge, number of circle and number of cross, which is larger. Okay, you say, oh, that's easy, this is 6, this is 4, 6 minus 4 is 2. Well, this one is artificial math. You created artificial math, and using the artificial math to say number of crosses larger is pointless. Okay, is minus 2, we can make this math and make it work. Okay, no problem, we can make it work. Okay, you can't use this kind of artificial math to say number of crosses larger. Only way you can tell is you make a correspondence. This one we have a leftover, so this number is larger. Okay, so this principle of comparing number work no matter how large the group is. For example, you take number line 0, 0. I want you to compare the number of positive integer and number of integer. So you have 1, 2, minus 1, minus 2. Positive integer, we count only this one, but all the integer we count both sides. So you see, of course this guy is larger. You compare this way. Is that so? Not really. What we do is we make a correspondence. We make a correspondence this way. So it's keep going. So this one all covered. So there's no left over on this side. You can do correspondence forever, right? And that's why this number of positive integer is infinite, number of integer is infinite, and this infinite minus infinite, what is it? In this case we can say 0. Well, first of all, you use artificial math, said okay, infinity minus infinite is 0 because they are same. No, infinite is not in this artificial math. This infinite and this infinite is different. The infinite type A and type B, and you subtract, you cannot set 0. Okay, so what do you do? For example, 1 over delta minus delta square, and delta goes to 0. What do you do? Then delta goes to 0, and delta square delta minus 1, right? Okay, so infinity minus infinity become like this, right? So obviously what's happened to this? Does this become 0? Think about it. This goes to 0. This goes to 0. It looks like it goes to infinity, isn't it? Okay. Think about this, right? So this case exists, right? You have bunch of limit x goes to 0, fx gx. Find this limit. You do this kind of exercise a lot in high school, and fx can go to infinite and gx goes to infinite. So you have to manipulate this down to only few x left, so you can guess which way it goes. This can go 0, normal number, or infinite. Okay, the same thing, fx minus gx, limit x go to 0, and which number it's going to take. So infinite is something you cannot use this whatever the math you learn. And that's the reason, everybody get confused when they learn calculus, because calculus use plenty of this. Okay. Next subject we move to integral. Integral is basically what? You deal with infinitesimally small number. It's almost zero, but you add infinite amount. Then what's happened? Okay. It can go infinite. It can go normal number, or something else. Okay, so you constantly deal with this kind of problem. It's infinite, and that's the calculus. So you have to live with concept of infinite in the calculus, and that's the most important things when you learn calculus. Live with the concept of infinite. Careful, you can't use this common sense artificial math for infinity. A lot of contradiction, controversial logic can be created using infinite. You have to be very careful. Okay, that's all for today. So next one we are going to move to integral. Okay, so if you like this video, please subscribe and put any comment you like. I try to read it and respond. Okay, see you then.